Hello, my dear students. This is Mrs. Shayma Gharib and today's lesson about rotational symmetry. This PowerPoint is created by Engineer Abir Sabri. Let's start by revising some rules before you watch any video. First, you have to sit in a quiet place. You should have your pen and a piece of paper to take notes and to solve the questions. You should pause the video after each question, then you try to answer on your own. Then you play the video to check your answer and to understand the question in case you get a wrong answer. Are you ready? Let's start. First, let's revise the turns and how the shape could rotate or turn. For example, this is called a quarter turn and its size is 90 degrees. Now, if I completed the turn to be half turn, and it equals 2/4 turn or 180 degrees. If I completed the turn this way, it will be 3/4 turn, and its size is 270 degrees, and it's equal to 3 right angles. Then the full turn or 1 whole turn, which is 4/4 or 4 right angles, and its size is 360 degrees. So let's start. The meaning of rotational symmetry. When we turn this spinner around the center point, this is the center point, you can see the same shape appears if we try to rotate it for a full turn. So a shape has rotational symmetry when it looks the same more than once through a rotation around the center for 360 degrees or through a full turn. Let's see how. The order of rotational symmetry of a shape is the number of times the shape looks the same in one full turn. So this is the shape. Now I'm going to rotate it around its center here for full turn. So it will make one whole turn. Let's see how many times this shape will look the same during this full turn. Let's start and see. This is the start point. Okay, let's see. After the shape rotate for 360 degrees, it is back to its original position. So now let's see how it rotates. So this is the first one. It looks the same. Then after moving it, it will look the same 2 times. Now I finished a full turn, and through this full turn, the shape looks the same 3 times, as you can see, which means the order of rotational symmetry for this shape is 3. So this is the meaning of order of rotational symmetry. How many times the shape looks the same through a full turn. Let's try more shapes. Let's start with quadrilaterals. And let's remember the quadrilaterals. They are 2D shapes. They have 4 sides or edges. They have 4 angles and of course 4 vertices, such as the square, the rectangle, parallelogram, trapezium, rhombus, and kite. So let's talk about one by one. We'll start with the square. As you can see, this is a square. We put this point here just to identify the starting point. Now we are going to rotate this square for full turn, which means this point will be back to this position after full turn. Let's see how many times the square will be the same through this turn or a full turn. Are you ready? Let's start. So this is the first time. It looks the same. I will complete rotating, so this will be the second time. And this is the third time. Then it is back to its original position after a full turn. And through this full turn, the square back to its shape exactly 4 times, which means the order of rotational symmetry for any square is 4. Is this clear? Now let's try the rectangle. So this is the start point. I'm going to rotate the rectangle 1 full turn until this point back to its original position. So let's try. Is this the same? No, not yet. Now it's back to its original position. So this will be the first time. It's not. And finally, it looks the same after or in 2 times through a full turn, which means the order of rotational symmetry for any rectangle is 2. What about the parallelogram? We'll do exactly the same. I'm going to rotate the parallelogram for 360 degrees or a full turn. Let's start. No. Yes. So this is 1. No. I will complete rotating until I reach or I finish a full turn. So through the full turn, it is repeated 2 times, which means the order of rotational symmetry is 2. What about the trapezium? We'll do exactly the same. I will start to rotate the trapezium 360 degrees or 1 full turn. It does not look the same so far. Still not the same. At the end, it looks the same, which means the order of rotational symmetry is 1. Now let's try the rhombus. I will start to rotate. It's not the same. Yes, it's the same. Once. No. Yes, at the end. So order of rotational symmetry of the rhombus is 2. Okay. Now let's try the kite. I will start to rotate. Not the same. Not the same. Not the same. Finally, at the end, it looks the same, which means the order of rotational symmetry for any kite equals 1. Now, let's sum up the information we talked about. So, here are some shapes. The square. The square has 4 lines of symmetry, and the order of rotational symmetry is 4 as well. For the rectangle, it has 2 lines of symmetry, and the order of rotational symmetry is 2 as well. For the parallelogram, it has no lines of symmetry, and the order of rotational symmetry is 2. For the trapezium, for this trapezium, it has only 1 line of symmetry because this is an isosceles trapezium. An order of rotational symmetry is 1. But there are other types of trapeziums that have no lines of symmetry. So according to the type of trapezium, we write the lines of symmetry. But the order of rotational symmetry for any trapezium is always 1. For the rhombus, it has 2 lines of symmetry, and the order of rotational symmetry is 2. For the kite, it has 1 line of symmetry and order of rotational symmetry 1 as well. So it's really important to know the name of each shape and how many lines of symmetry does each one have, and what is the order of rotational symmetry for each one of the quadrilaterals. And of course, you have to know how each quadrilateral looks alike, okay? Now let's talk about regular polygons. What the meaning of regular polygons? Regular polygons are 2D shapes. All sides are equal and as you can see here, all the sides are equal in length and all angles are equal in size. So all the internal angles, as you can see, equal in size. So if the shape only has equal sides without equal angles, it will not be regular polygon. They both must be there, equal sides and equal angles at the same time. Now let's try the first regular polygon we have, which is regular pentagon. So let's try to rotate the regular pentagon and see the order of rotational symmetry. As we said, we are going to rotate it for a full turn until it is back to its original position. So now let's start. 1, 2, 3, 4, 5. So it looks the same 5 times through a full turn, which means the order of rotational symmetry for the regular pentagon, not any pentagon, it has to be regular, is 5. Okay? What about this hexagon? It is regular hexagons. All sides are equal and all angles are equal. Let's start to rotate. So 1, 2, 3, 4, 5, 6 at the end, which means order of rotational symmetry equals 6. What do you notice so far? Any regular polygon has an order of rotational symmetry that equal to the number of sides. Let's check. The order of rotational symmetry of a regular polygon is equal to the number of sides. So for example, this one has how many sides? It has 8 sides. It's regular octagon, which means order of rotational symmetry of a regular octagon will be 8 as well. Now let's talk about triangles. I will start with equilateral triangle. The equilateral triangle has 3 equal sides and 3 equal angles, which means it is a regular polygon. So we can guess the order of rotational symmetry. As we said before, for any regular polygon, it's same number as the number of sides. It has 3 sides, then the order of rotational symmetry of it will be 3. Let's see how. I will start to rotate. 1, 2, and 3 through a full turn, which means order of rotational symmetry is 3. Let's try one more type of triangles, which is the isosceles triangle. It has 2 equal sides and 2 equal angles, and it has only one line of symmetry. You can watch the video of quadrilaterals to know more about the properties of quadrilaterals and 2D shapes. I will start to rotate. As you can see, it doesn't look at the same just once at the end, which means order of rotational symmetry is 1 for the isosceles triangle. Now let's try the scalene triangle. I will start to rotate it for a full turn around the center. Look, it didn't look the same only once at the end, which means order of rotational symmetry for the scalene triangle is 1. So the only type of triangle that has order of rotational symmetry that's 3 or more than 1 is the equilateral triangle. Okay? Now let's sum up the information that we said about types of triangles. The first type we had was the equilateral triangle. This is its shape. How many lines of symmetry does it have? It has 3 lines of symmetry. And the order of rotational symmetry is 3 as well. Second type, isosceles triangle. This is the shape of the isosceles triangle. Lines of symmetry is 1 line of symmetry, and the order of rotational symmetry is 1 as well. Then the scalene triangle, all sides are different and all angles are different. Lines of symmetry, it has no lines of symmetry or zero lines of symmetry. An order of rotational symmetry is 1. What about a right-angled triangle? Look at this one. It is scalene right-angled. All the sides are different. So there is no lines of symmetry, and the order of rotational symmetry is 1 as well. There is another type of right-angled triangles, which is an isosceles right angle. It has two equal sides, and in this case it will have one line of symmetry and order of rotational symmetry 1 as well. Is this clear? You have to know the different types of triangles and the number of lines of symmetry for each one and the order of rotational symmetry for each one. Is this clear? Now our questions time. Write the order of rotational symmetry of the following shapes. Look at the first shape. Does it have any lines of symmetry? No. So it has no lines of symmetry. Then the order of rotational symmetry will be 1 because it will appear just once at the end of a full turn rotation. Then its order will be 1. What about the second shape? Let's see. I will rotate it for a full turn. This is 1 time, and at the end another time. So the order of rotational symmetry will be 2. What about this shape? Let's check and see. It didn't look the same at all through the full turn, only at the end of the full turn, which means it has order of rotational symmetry 1. Okay, is this clear? Now, fully describe the rotational symmetry of the following shapes. What the meaning of fully describe? Fully describe the rotational symmetry means write the rotational symmetry order or the order of rotational symmetry for each shape. I have here the first one is a heart. If I will start to rotate it for a full turn, it will not look the same until I get the end of the full turn, which means it's once at the end. So the order of rotational symmetry is 1. What about this smiley face? If we have inside pattern, we should keep it as it is. How that? It's not a circle. It is a shape. So when I rotate it for a full turn, it will not be the same until I get the end of the full turn. So it will be once at the end. Then the order of rotational symmetry will be 1. Okay? What about this shape? It has 5. As you can see, whenever you rotate it, this part will be exactly on this part. So it will be repeated 5 times through a full turn. Now, fully describe the rotational symmetry of the following pattern. Look at this pattern. What do you think? If I start to rotate it for a full turn, how many times it will be the same through the full turn? Yes, it will be 4 times. Every time you rotate it, it will look like the same every each quarter turn. Look at this one. All the triangles here are equilateral triangles. So when I start to rotate this shape, full turn, it will appear 3 times through one full turn. So the order of rotational symmetry for this shape will be number 3. What about this one? What do you think? It's a rectangle, but not all the tiles are the same color. And this is very, very important. And take care of this because it's really important to notice what will happen through the full turn. Think. It will only be repeated 1 time at the end of the full turn. So the order of rotation for this pattern will be 1. Now look at this grid. On this copy shade in 5 more squares so that the pattern has rotational symmetry of order 4. In this question, he gave you this grid with some shaded squares, as you can see, and he's asking you to shade in 5 squares more so that the pattern has an order of 4. So how can I make the rotational symmetry of order 4? By shading 5 more squares. Let's see where are the 5 more squares that we can shade. So now I have this one, then this one and this one, then this one and this one. As you can see, you can find the pattern here. 2 shaded, 1 not, 2 shaded, 1 not, 2 shaded, 1 not, 2 shaded, and 1 not shaded. In this case, when you start to rotate this shape for a full turn, you will have order of rotational symmetry 4. Okay, is this clear? Let's see together. Look, this is order 1. Second time, third time, and last time. Then the order of rotational symmetry for this shape after shading 5 more squares is order 4. This is the end of our lesson today. I hope you enjoyed the video, and if you have any question, please feel free to leave a comment and I will answer you as soon as possible. Please remember that your feedback is highly appreciated. Thank you very much and have a nice day.